Hello everyone. Today we're looking at resonance structures and we're going to use the chlorate and the phosphate ions as our examples. Before I look at these structures, I want to quickly look at a definition for resonance structures. Now, resonance structures, they are closely related to Lewis structures. In fact, they are based upon Lewis structures. So resonance structures represent the different forms of the same Lewis structure where the electrons have been transferred from one region to another. In other words, the electrons are transferred from one set of atoms to another set of atoms, or the bonds will be shifted from one place to another. So let's look at our chlorate ion to demonstrate this. Before I start, I want to point out a few things. Firstly, I want you to note that there is a charge on one of the oxygen, and we know this by drawing the Lewis structure with the lone pairs of electrons and also determine the formal charges on the atoms. Now, I'm doing these structures to make it easier because we're focusing on the bonds. But when you're drawing it, please remember to put your lone pairs of electrons and also to determine your formal charges. It will be better and clearer. Now, if you look at the structure, you would realize that there are two double bonds and a single bond. Now, there's no certainty that that single bond must be placed on the oxygen on the left. It could be between any of the oxygen. So what we can do now is to shift that single bond around. But when we shift the single bond around, all the structures that we get must equal to this very structure. So one possibility here, we shift the single bond to the top oxygen, and I want you to note that the negative charge or the formal charge on that oxygen will also be shifted, because if the double bond replaces the single bond, then also the number of electrons, or let's say the number of lone pairs of electrons, will be affected. And so if you think about the number of bonds versus number of lone pairs, you know that they must add up to 8, following the octet rule, right? So looking at the structure now, you'd realize again that that single bond on top could also be shifted to the oxygen on the right. So therefore, we could get another structure looking like this. So now we have three possible structures that are equal, and hence we call these three structures resonance. Now let's jump into the phosphate ion. Again, we're representing the phosphate ion as basic structures. And so in this case, we have three single bonds and a double bond. So this time, we're going to shift around the double bond. And if you notice the double bond in white, so it make it kind of easier for us to observe as well. So think about it and think about how many possible resonance can we have here. And if you can shift around that double bond with replacing those three single bonds, you realize that we have three other structures with this one. So it'll be 4 total structures. All right, so let's make a shift and shift that double bond up to the top. We will have a structure looking like this. And also notice the charges are only on the oxygen atoms with the single bond. The double bonded oxygen will be a formal charge of 0, okay? And so let's shift the double bond to the oxygen on the right. And now we have another structure looking like this. Can we shift it any further? Oh yes, definitely. We could shift it to the bottom. And so we could have another structure looking like this. So there are 4 possible structures that are equal to each other. The only difference here is the position of the double bond. Okay. Last thing to point out before I move, if you notice the negative charges on the oxygen with the single bond, it gives the entire phosphate ion a charge of -3. All right. So just to point that thing out. All right, so now we are going to close, and I hope this was really helpful for you. And I want to tell you, like always, I appreciate you watching these lessons. And please remember that while we change, or we may change, that we should always maintain our integrity. In other words, maintain who we are, always be true to ourselves. All right, have a blessed and wonderful day. See you next time. Keep safe.